This is Rajesh, Assistant Professor of Department of Civil Engineering at Bharat Institution of Higher Education and Research. Today I'm going to present a lecture about introduction to fluid mechanics. So the topic is about basics of introductions of fluid mechanics. So first we're going to discuss about the definition of the basics of fluid mechanics. So first we're going to see about the what is a mechanics. In the mechanics, the mechanic is a oldest physical science that deals with the both stationary and the moving body under influence of force. So in this, we're going to discuss about the mostly about the properties of the fluids and the waters we're going to find. So mainly, fluid mechanics we're going to study about the properties of the fluids. It is about the velocity and the speed and how much distance it has been traveled we're going to find. In the conditions, we have three conditions we're going to study about the statical condition and dynamic conditions. Is mainly we're going to see about the dynamic and in a static condition you're going to see. S- Now, the first point is we're going to discuss about the first is a branch of mechanism that deals within a body at rest is called as statics. What is statics means? It is a body at a rest is we called as an statics. Why the branch that deals within a body in motions we called as a dynamics. Okay, the subcategories of a fluid mechanics is defined as a science that deals with an behavior of the fluid at rest. Behavior of fluid at rest we call as an fluid statics, or in motion we call as an fluid dynamics, and it interaction of the force within a solids or other fluid at boundaries. Other is a boundaries. So this study of fluid is a rest. This is a study of um, a study of fluid at rest is called static. The study of fluid in motion, where a pressure force are not considered, is called fluid dynamics. And if a pressure force are also considered for the fluid in the motion, that branch of science called dynamic fluid dynamics. A fluid dynamics itself is also divided into several categories. A study of motion of fluid that is a practically incompressible, such as liquid, especially water, and its gases at a lower speed, is usually referred to as an hydrodynamics. A subcategories of the hydrodynamics is hydraulics, which deals with the liquid flow in pipes and open channels. So, hydraulics is we going to see in the open channels and the pipelines. So, this is mainly where it has been used. Means it is used for the our agriculture structures. The water has been displayed from the um, passes from one point to the another point. It may be an open channel or that may be now open channel. So open channel, it is been we can able to see that is an um, channel for the one a canal. A water has been distributed to the agriculture. So open channel, we have a different shapes. We have been culverted and different materials. We have been constructed constructed based on the concrete which actually constructed. That is, we have in a lined channel as unlined channel. In a open, in the closed circuit like a pipe, we have been using only a steel pipe. We have been using for the nowadays for the distributing a water from one point to the another point. So that one point to another point, we have been distributing the pipe only. We're going to study in the fluid mechanics. So in the hydraulics, we will study about the open channel flow, which has been taking a water from the one point to another point. We have been distributing to the many areas. We have been supplying a water to the many areas. So what is fluid? So A substance exists in three primary space, that is a solid, liquid, and gas. A substance in liquid or gas space is referred to a fluid. A solid and fluid is made on the basis of substance ability to resist or apply a shear that extends to change its shape. A solid can resist and apply a shear stress by deforming, whereas a fluid deformed continuously is under the influence shear stress no matter how small. A solid stress is a proportional to strain, but is a fluid stress is a proportional to the strain range. In a liquid, a molecules can move relatively to each other, but then a volume remains relatively constant because of constant cohesive force between the molecules. As a result, it takes shape of the container. So we are given here a two diagram which is given here the in one beaker and another beaker we have been one is filled with a liquid, another one we have been filled with a gas. We can able to see up to a certain limit the water liquid has been filled at remaining point it has been leave for a free space. So the result as a result of a liquid takes a shape of the container. It is in a it forms of a free surface in a larger container in a gravity field. A gas on another hand is expand unital in a contour of that wall of the inner container and is fill the entire available space. So in this container, it will be occupy all the space, total space. This is because the gas molecules are widely spaced and the cohesive force between them are very small. Unlike a liquid, gas cannot form a free surface. So, so next we're going to discuss about the difference between a liquid and gases. So we given a 3 points is based on the now what is a liquid and what is a gas we are going to learn. So liquid and gas. As first we can go to discuss about the liquid. A liquid, first one, it is a difficult to compress and is often regarded as incompressible. So we all know that that is a liquid is incompressible. Okay. So next is we have been a seed in a previous in a container we have been filled a liquid up to a certain number we have been filled its volume has been increases to a certain limits. It is occupied a fixed volume and it will be takes a shape under container. So third point is a free surface is formed if the volume of the container is a greater than the liquid. So gases. So gas is easily to compress. It changes of volume is large. This cannot normally be neglected and or related to the temperature. So no fixed volume. It changes a volume to extend to fill the containing vessel. So third point is a completely fill the vessel so that no free space is formed. So when we compare this, so we can able to know about the liquid and the gases. So liquid is incompressible, but gases is uncompressible. So in this liquid, how much space is available based on the space only we can able to fill that liquid. And in the gas, it won't be no space will be provided in the vessel. So vessel means we have been seen in the picture and last previous slide that has been shown here. In that it has been occupied how much quantity it has been occupied and the liquid and the gas in the vessel. That is we call this another word we call this as a container. So now we came for the properties of the fluids. So properties of fluids figure, we're going to enter the properties of fluids. Any characteristics of system is called only property. So I told you at the beginning, we're going to find the velocity, pressure, temperature, mass. So these are the main thing we're going to see or we're going to discuss. Some of the familiar properties are pressure, first one, temperature, second one, volume, third one, mass. So based on this only we're going to discuss. So other less familiar properties includes viscosity, thermal conductivity, modulus of elasticity, thermal expansive cohesive, electric resistivity, and even a velocity and elevations. The properties are considered to either incentive or extensive. So what is incentive means independent of mass of systems such as temperature, pressure, density. Intensity of properties is mainly it is depends on mass of the systems. Extensivity properties is depends on size or external systems. So total mass, total volume, total momentum or even some of the example for this. So there is a difference between the two. There is a one is the in independent. So independent of mass such as temperature, pressure, density. So next is dependent on size or extent of various systems. That is the total mass, total volume, and the total momentum. As an example for this both. So now we can able to see the properties of fluids. The easy way to determine whether the properties incentive or excentive to div- is to divide the system into two equal parts with the imaginary partitions. The each part will have the same value of an incentive properties as original systems, but off of the values of extensive properties. So we can able to see that image above the image we have been splitted here. So that is we have been discussed that is a mass, viscosity, temperature, pressure, density. So that only we have been discussed in the previous slide. See pressure, temperature, volume, mass. So that only we have been given in this box. So we have been split into two. So now we're going to see about the discuss about the first one of the property of fluid as a density or then a mass density. So if we calculate a density or the mass density, then only we can able to solve some problems are based on the density and the mass density. So what is the density? Density or mass density of the fluid is defined as the ratio of the mass of fluid to its volume. Thus, mass per unit volume of the fluid is called density. Okay. So it is denoted by symbol rho. The unit mass of the density in SI unit a kg per cubic meter. Since it's a kg per meter cube, it will taken as a kg per meter cube. The density of liquid may be considered as a constant while the changes consider a constant while that the gas changes with the variation of pressure and temperature. So by the mathematically the mass density is written as so rho equals to mass of fluid divided by volume of fluid. Mass of fluid divided by volume of fluid. So the volume of density of water is 1 gm per cm cube, that is a gram per centimeter cube, or 1000 kg per meter cube. So we have been calculated into, we have been converted into 1 kg per meter cube. So always we have to convert the unit is very important for calculating for the properties of fluid. In this chapter, we going to fully we going to conversions of the all the units. So next one is density or mass density. The density of substance in a general deposit on temperature pressure. The density of most gases is proportional to pressure and inversely proportional to temperature. The liquid and solids, on the other hand, essentially encompass substance and variation of variation of the density with the pressure is usually neglectable. So next one is a specific weight or weight density. So we have been discussing only definitions and then a formula for the each properties of the fluid. So now we're going to discuss about the specific weight or weight density of the fluid. The specific weight or weight density of fluid is the ratio between the weight of the fluid to its volume. Thus, the weight per unit volume of fluid is called weight density and it denoted by symbol W, that is a small w. In a mathematically, we're going to express it. So mathematically, a small w, we have been a symbol, we have been a sufficient for that is a small w for the density, weight density. So weight density equals to weight of the fluid particles divided by the volume of fluids is equal to, so weight of the fluid, we're going to consider a mass of the fluid into acceleration due to the gravity. So gravity is a very important here. Is divided by volume of fluid. So next point we have been taken now a mass of fluid into g. It is an acceleration to the gravity. We have been a symbol that is we have been denoted as symbol g divided by volume of fluid is equal to rho into g. So small w equals to rho into g. Specific volume. A specific volume of fluid is defined as wa- uh, volume of fluid is occupied by the unit mass or volume per unit mass of the inner fluid is called a specific volume. Its mathematical expressions, a specific volume, a volume of fluid divided by mass of fluid. So this we can able to in a mathematically expressions we can do that. 1 divided by mass of fluid divided by volume. So 1 by rho as is expressed in a volume is the reciprocal of mass density. It expressed as meter cube per kg. It is commonly applied to gases. So next one is a specific gravity. So we have to find how much gravity while we are finding for the fluid conditions. So the fluid gravity is defined as a ratio of the weight density or density of fluid to the weight density or density of the standard liquid. For liquid, the standard fluid is taken of water for gases. The standard fluid is taken and air. A specific gravity is called relative density. It is a dimensionless quantity and is denoted by a symbol S. So S stands for liquid. So equal to the weight weight density of the liquid divided by weight density of water. For gas, next one is for gas. We are going to separate it for the liquid and gas. So for the gases, so weight density of gases divided by weight density of the air. Thus, the weight density of a liquid equal to S into weight density of water. So that is S into 1000 Newton per meter cube. So that's the density of liquid S into density of water equals to S into 1000 kg per meter cube. So the specific gravity will be vary for the all the following substance. So for the water, it will be 1 for blood and sea water. Okay, so mercury, wood, gold, bones, ice, air. So for this we have been as pictured here. What are the specific gravity will be the? So here we again taken a small example for the specific gravity for the mercury is 13.6. So we all know that there is a specific gravity of the mercury is a 13.6. So we have to multiply into 1,000. So we'll get an 1,000, 13, um, 13,600 kg per meter cube. So based on this, we're going to solve one problem on this conditions. So first problem is we're going to calculate the specific weight of the density and specific gravity of 1 liter of an liquid which weight is 7 Newton. So a solution, a given data. So only a given data, the volume, 1 liter they given, we have to convert into a meter cube. So 1 divided by 1000. Since 1 liter equals to 1 by 1000 meter cube or 1 liter equals to 1000 centimeter cube. So the weight they given us 7 Newton they given. So what we're going to find in this, we're going to find the specific weight, we're going to find density, we're going to find and specific gravity we're going to find. So we're going to find then three we're going to find. So first we're going to find about the specific weight. So weight equal specific weight equals to weight by volume. So they given a weight value here. So weight value is a 7 Newton divided by volume. So volume we know that 1 by 1000 meter cube. So when we calculate this, we'll get a value of 7000 Newton per meter cube. So next one is the density. So density equals to W by G. So W, we know that we have been calculated that there's a specific weight. So 7,000 divided by 9.81 of a kg per meter cube. So we get the answer of an 713.5 kg per meter cube. So next one is a specific gravity. Specific gravity. The density of liquid divided by density of water. So density of the now we have been already we have been find it that is a now 713.5 divided by 1000. So we know that the density of water is 1000 kg per meter cube. So from that we have been find an answer 0.7135 is an answer. So we have been find a specific weight value, density value, and then a specific gravity value. So by using this formula, what we have been previously we have been formula we have been derived based on that. So second problem we going to calculate the density specific weight of the 1 liter of the petrol of the specific gravity is equal to the given zero point 0.7 they given. So now a given data, the volume 1 liter equal to 1 into 1000 centimeter cube. So 1000 divided by 10 to the power of 6 meter cube equals to 0.01 meter cube. So specific gravity they given S equals to zero point 0.7. So density that we go known as a symbol is a rho. So density equals to S into 1000 kg per meter cube. So we'll get a zero point 0.7 into 1000, we'll get 700 kg per meter cube is the answer. So now first they ask in the question what we have to find specific weight, a small w. So specific weight equals to what's the formula for us? The given formula is W equals to rho into G. So 700 into 9.81 Newton per meter cube will get an 6867 Newton per meter cube. So next one we have to find in a weight, that is a W. So we know that a specific weight formula, the weight by volume. So W equals to weight small w equals to W by 0.01 or 6867 equal to W by 0.001. So we'll get the W equals to 6867 into 0.001. We'll get a 6.867 N Newton. That is Newton is the answer we'll get. So next one is the viscosity. So viscosity, we're going to discuss about the properties of viscosity. So here we can able to see here the viscosity. Viscosity is a definition of defined as a properties of fluid which offer resist to move on one layer of the fluid over another layer. to the adjacent sides. Okay, the two layers has been a fluid of that is a dy apart is move over the another different velocity. We can say that is a u and u plus du as shown in a picture. We can able to see the picture. The viscosity is together is relative velocities causes shear stresses acting between the two layers. So we can take an example as the water it has been flowing in the seashore that is a wave. So one layer it will passes again that is still acting upon a shear stress has been acting on the waves. So which has been moving and taking a place of the water to which is fast. So like that only here also it will be a reaction it's just moving from one point to the another point. You can able to see this velocity profile picture had been shown here. That is when we can able to see in x-axis and the y-axis. So x-axis we are given a u and y-axis we given a y. So based on that, we can just see that a curve is pushes it with a velocity profile. It has been traveling from one point to how much it has been. It start from a zero and it has been increasing to some point. It has been decreasing. It has been traveling. So it's widely it has been increasing. So the shorter point it has a u. After that, it has been increases to the u plus du that is been given here. Okay, it has been a travel to some distance. Why? So the mu we call as mu is a constant proportional is known as a coefficient of a dynamic during a dynamic condition how much it is when the flow is moving. Dynamic viscosity or only a viscosity that we call as a du by dy is represents the rate of a shear strain or a rate of a shear deformation of the velocity gradient is given in an equation as a mu equals to tau du by dy. The viscosity is also defined as the shear stress is required to an proceed a rate of change of shear strain. So, unit of viscosity. The unit of viscosity obtained by putting the dimensions of the quantity in equations. So, mu equals shear stress by changing velocity divided by changing velocity divided by changing distance. So, this is equal to shear stress equals to we know that a force per area. So here, a changing velocity is a length by time. So distance is 1 by L. That is a length. So we derive this the force by length L square by 1 by time is equal to force into time into L square. In SI unit with viscosity, the Newton second meter square, ns by meter square. So next one is the kinematic viscosity. It is defined as a ratio between a dynamic viscosity and the density of fluid is denoted by a Greek word V. So as in a mathematically, the V equals to mu by rho. That is the density. So n is unit in SI unit. As a kinematic viscosity is meter square by S. That is a second meter square by second. So Newton's law of viscosity that states that the shear stress that is a tau that is because symbolism and tau of the fluid layer is directly proportional to the rate of shear strain is a constant proportional is called a coefficient viscosity. Some mathematical expression is given in an equation. Is a mathematical it is a given in an equation. So those equations is a mu naught at the 1 plus beta square. So we have types of fluids here, the four types of fluids here. It is ideal, real, Newton, and non-Newton fluids are here. So which it has been passing something, how much it has been, that it has been traveling from one point to another point. So ideal fluid is incompressible and no viscosity. Okay, real fluid is an hypothesis of the viscosity is a real fluid actual practice. Newton's fluid is a shear stress is directly proportional to the shear strain. Non-Newton is a real stress and not proportional to the rate of shear strain. So R is a velocity gradient. is known as non-Newton. So this one is the ideal square and the plastic. This is an actually flow graphical method. It has been represented that the velocity gradient of an du by dy as a shear stress. So based on this, we can discuss one of the problem. If the velocity distributions of plate is given by u equals to 2 by 3 y minus y square, um, in which u is velocity meter per second at a distance of y is a meter above the plate is determined the shear stress at a y equals to 0 and a y equals to 0.15 meter. Take a dynamic viscosity of fluid as an 8.63 poisons. So now the given value is u equals to 2 by 3 y minus y square. We have to differentiate it. We will get it that du by dy equals to 2 by 3 minus 2y. So now we're going to apply here du by dy equals to first they given a first it is given a 0, another y they given how much distance it will travel is 0.15. For a both we are going to calculate here. First we are going to calculate for the y equals to 0. So 2 by 3 minus 2 is 0 into 0 2 by 3 you will get an a 0.667. So for the next one, for the now y condition, we'll get we are substituting the value of a 2 by 3 minus 2 into 1.5, 0.15, it will get a 0.667 minus zero point 0.3, we will get an answer of 0.367. So mu value the given is 8.63 Poisson. So Poisson we have been converting, so that we have been converting in a SI unit for the Newton's Newton is mi square. So we have to divide it by 10. Okay. So we have a formula that is stress um, equals to mu du by dy. The shear stress at y equals to tau equals to 0. So mu by dy equals to, we have been substituting. So we know that the value for mu they given the question itself 8.63 into we have been a calculated du by dy value we have been a calculated that is a 0.67 is equal to 0.756 Newton meter square. So shear stress for the 0.15 meter. So tau equals to 0.15. So mu equals to du by dy for 0.15. So we're going to substitute the values is equal to 0.63 into 0.367 equals to 0.1 0.3167 Newton per meter square. So calculating for the dynamic viscosity and oil, which is used for the lubricate between the square plates of the 0.8 meter and 0.8 meter, is the incline of the angle of 30 degree as shown in a figure for the square plate of the 300 and as a slide down the incline with an uniform of the velocity of the 0.3 meter of thickness of the of fluid. So in this also same we are using a tau equals to force by area. So 150 by 0.64. So tau equals to mu du by dy. So dy equals to that is a distance how much it has been traveled given t equals to 1.5 into 10 to the power 3. So we're substituting all the values in the formula and we'll get in a value of Poisson of 11.7 value we'll get. So thank you.